have it written as a quiz. I may end up counting it as a test on Tuesday. I'll let you know for certain Friday. Yes.
Is that you postponing the quiz on Friday to Tuesday?
Yes. Yes. All right. I'll let you know for certain on Friday, but it may end up being a test instead of a quiz. Okay. Is this the one that we had on our homework quiz? Yeah. Okay, so what are we going to do first? Huh? Oh. Okay, what do we do first here? Okay. Okay, so you moved it over this way? Did everybody do that? Okay. I actually moved it the other way. Doesn't matter. Ultimately, you'll end up moving it. But the only reason was I saw that if I moved the 4 cosine square over, I was going to end up with a negative 2 cosine squared. So I wanted to keep everything positive, so I subtracted 2 cosine squared from both sides. It's not wrong if you do it that way. I just want to keep that first term positive. So I'm going to subtract the 2 cosine squared, so I get 2 cosine squared over here. That takes care of that. Now I have to move everything else over. Okay, so I'm going to have minus 3 cosine theta plus 1. Everybody okay with that? All right. So then we have to factor. This is going to factor 2 and 1, 1 and 1. They both have to be negative. Okay, so we get 0 equals 2 cosine theta minus 1 times cosine theta plus or minus 1 again. So 2 cosine theta minus 1 equals 0. So we have 2 cosine theta equals positive 1. So cosine theta equals 1/2. And over here, we're going to get cosine theta equals negative 1. Okay. And that means that theta equals the inverse cosine of 1/2. And over here, theta equals the inverse cosine of negative 1. So then looking at our unit circle, where is the cosine equal to 1/2? Yes.
You made a mistake on the right side. It should be cosine theta.
Positive 1. Thank you. Yes. Good. Thank you very much. Okay, so where is a cosine equal to 1/2? Well, here it's square root of 3 over 2. So that means it has to be right here. So theta equals, what degree is that? 60. And then cosine is negative over here, so I've got to come back down on this side. This is where cosine is positive. So we're looking right here also, which is 300 degrees. And then where is a cosine positive 1? Right here at 0. Now on the quiz, did we include 360 or just the 0? Just the 0. Okay, so that's our answer. 0 degrees, 60 degrees, and 300 degrees. Da-da-da-da-da. How'd you do? Good? Okay. Okay, did you have any other questions from the homework? From that worksheet? No? Okay. I'm looking at the video from first period just because I want to be consistent with what I'm giving you, what I'm going over. Let's see here. Okay. Okay, so let's look at some other examples. So far, we have looked at solving basic trigonometric equations, And then we just looked at solving ones that are in the quadratic form that we could factor. Okay, here's another one. Let's look at 4 cosine squared x minus 3 equals 0. What do you think we could do to solve this? Any thoughts? Kevin? Move the 3 over. Okay. All right, that's a good start. Now what? Okay. Divide by 4. Excellent. Okay. Now what? Let me ask you this. If we had x squared equals 3 over 4, how would you solve that? Square root both sides. So we're going to do the same thing. We're going to square root both sides. So we get cosine x equals plus or minus the square root of 3 over, we know the square root of 4 is 2, so over 2. So now when we look, right, we've got x equals the inverse cosine of plus or minus the square root of 3 over 2. Okay, so now when we look at our unit circle, we're looking to see where cosine of the angle will give me the square root of 3 over 2. Cosine is the x value, so we're looking to see where the x is the square root of 3 over 2. And where's that going to be? Which angle has an x value square root of 3 over 2? 30 degrees, right? So remember, we can use our calculator to help us a little bit, right? Let's go back to our calculator. Okay, so if I do inverse cosine of the square root of 3 divided by 2, I get 30 degrees. So our calculator can help us by giving us that reference angle. So I know that I'm looking at 30 degrees. So I'm going to find all the other 30-degree reference angles. So I've got one right here, one here, and one here. So this is at 150, 210, and 330. All of those are answers because we're talking about positive and negative square root of 3 over 2. So x is going to equal 30 degrees, 150 degrees, 210 degrees, 330 degrees. And we're done. Okay? So we can use our calculator to help us get that reference angle. Okay? Also, excuse me. Okay, if I graph it, I can also look and see what's going on. Excuse me. Okay, let's put that in our y equals. So if you have your calculator, please do this with me, okay? Okay, so we've got 4 cosine minus 3. Okay. And to make sure my mode is in degree mode, how am I going to adjust my window? What's my domain? 0 to 360. What scalar would you use? I'm going to use 30 degrees, so each mark is going to represent 30 degrees. Okay. So let's graph this. Okay. Sorry. Okay, let me just tell you what just happened. Thanks. I solved the equation algebraically and I got 4 answers. When I looked at the graph, I only see 2 answers, 2 points where it's crossing the x-axis because the equation is equal to 0. So I knew something was wrong. So I went back because I got 4 answers and I only see 2 answers here. So I went back and looked at my equation and I realized I entered it wrong because it should be 4 cosine squared. And I just put in 4 cosine. Okay, so that's how I discovered the mistake. Now, unfortunately, your calculator, just clear this. When you put cosine in, see, it right away puts that parenthesis there. The square is supposed to be right here, like right above the S. But the calculator doesn't let you do that. So you put your x or theta in, close the parenthesis, and then square it. That's how you have to do it on the calculator. Okay, minus 3. Okay, now I see 4 points of intersection. Okay, so you have to know enough about your graph to know how to interpret it. When I graphed it initially, I got 4 solutions algebraically, but I only saw 2 on my graphing calculator. So that caused me to go back and check my entry. Now I've got it in as 4 cosine squared x minus 2, or minus 3. So is it intersecting in the right spots? Okay. Now, based on my answers that I got algebraically, I chose to have each mark represent 30 degrees. That way I can just easily count on the axis and figure out where they're crossing. So here it's crossing at 30, 60, 90, 120, 150. So 30 and 150, 180, 210, 240, 270, 300, 330. So sure enough, my solutions match what I have on the calculator. Okay. Questions on that one? Okay. We used a calculator to help us get started, right? Okay, let's look at one that I cannot use the unit circle for. So let's look at 9 cosine x plus 2 equals 3. So here we're going to start by subtracting 2. So we get 9 cosine x equals 1. So that means cosine x equals 1 over 9. So we're looking at x equals the inverse cosine of 1 over 9. Now I can't do that on my unit circle, so I have to use the calculator. Okay, so let's go to our calculator, and we're going to do inverse cosine of 1 divided by 9. Okay, wait for you all to catch up. Okay, and we get 83.62. So x is approximately 83 point, we'll just leave it at 6 degrees for now, okay? But I have to be careful because even in the problem above, I had 4 solutions, but how many did the calculator give me? 1. So I need to think it through, okay? The calculator gave me 1. So let's look at the unit circle again. We'll use that as our guide. 83.6 degrees. Well, that's going to be like here, right? This reference angle here, there's my 83.6 degrees. This is cosine. Cosine is positive there. Where else? This is quadrant 1. What other quadrant is cosine positive? 4. So that means in quadrant 4, I need to use that same reference angle of 83.6. So that means we're looking down here. I have to figure out what that angle is. How do I figure out what angle that is? Subtract it from 360. Yes. Because I'm looking for this angle here. So 360 minus 83.6. Oops. And that gives me 276.4. Okay, so those are my 2 solutions. I have to use my calculator to get that angle, but then I kind of have to reason through the rest of it. Okay. Questions so far? Okay, here's another type. Let's look at 4 sine squared x minus 2 cosine x minus 1 equals 0. Okay, I'm going to give you a couple minutes. I want you to work with your neighbor and see if you can figure this one out. Okay, work with your neighbor to see if you can do this. Okay, and I like what I hear, but you're at a point where you're running into trouble, right? Why are you running into trouble? Doesn't factor. Yes. Okay, so let me catch up with where you are. We're going to substitute the sine squared, right? Did I write this correctly? Yeah. So we know sine squared x plus cosine squared x equals 1. Therefore, sine squared x equals 1 minus cosine squared x. So we have 4 times 1 minus cosine squared x minus 2 cosine x minus 1 equals 0. So we're going to distribute the 4. 4 minus 4 cosine squared x minus 2 cosine x minus 1, which gives me negative 4 cosine squared x minus 2 cosine x plus 3 equals 0. Okay, everybody with me? Okay, so we have to move everything to the other side so that we can get that to be a positive number. Okay, or I can just flip the signs, right? Is that what you said? We could. It just makes the factoring. You can't just. You could multiply both sides by -1? That's fine. That's fine. That's fine. It's the same thing. Okay. So, does this factor 4x squared plus 2x minus 3 equals 0? That does not factor. How do you solve a quadratic equation that doesn't factor? Or the quadratic formula. Listen, completing the square is what the quadratic formula is. Remember that? So you don't have to complete the square. You can just use the quadratic formula. Okay? So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we've got x equals -2 plus or minus the square root of b squared, so that's 4 minus 4 times 4 times -3 all over 2a, so all over 8. So we get x equals -2 plus or minus the square root of 4 plus, say, 16 times 3 is 48 over 8. Okay. So we get -2 plus or minus the square root of 52 over 8. And let's see, 52 is 4 times 13. So this ends up being x equals -2 plus or minus 2 root 13 over 8. Let me just check my work. Okay. All right, and then this will simplify. X equals -1 plus or minus the square root of 13 over 4. So x equals -1 plus the square root of 13 over 4, and x equals -1 minus the square root of 13 over 4. However, what am I going to say? I just used the quadratic formula to solve for x, but it's not actually x, is it? It's cosine x, right? Because what we did is we took this equation and we changed it. We said, okay, 4x squared plus 2x minus 3 equals 0. So what we were actually doing is we were saying 4x squared, that's 4 cosine x squared, 2 cosine x. So in reality, cosine x is equal to -1 plus the square root of 13 over 4. And cosine x is equal to -1 minus the square root of 13 over 4. So when we did the quadratic formula, we were actually solving for cosine x, not x. But that gets confusing and it gets heavy feeling when you're saying cosine x equals -b plus or minus the square. So it's kind of like, just treat it like a normal quadratic equation, but don't forget at the end, go back and put the trig function back in instead of just plain old x. Okay? Okay. How are we going to figure out what what x equals here? X equals inverse cosine of negative 1 plus the square root of 13 over 4. So we have to use our calculator. Let's clear some stuff out of the way. Am I okay erasing this side? Okay. Okay, so we're going to use our calculator. So we're looking at the inverse cosine, okay, of negative 1 plus the square root of 13. I need to be very careful with the way I'm entering this. I'm going to go divide it by 4. Now when I do that, I realize this is going to take the square root of 13 divided by 4 and add negative 1 to it. So I need to add some parentheses in there. So I'm using my insert key to add those parentheses. Oops. Okay, now I've got negative 1 plus the square root of 13, that's sum, divided by 4. Okay, counting my parentheses, I have 2 left parentheses, but I have 3 right parentheses, so I have to remove one of those. Okay, 49.35, I'll round that to 49.4 degrees. Did everybody get that on their calculator? 49.4 degrees. So x is equal to 49.4 degrees. Okay, what do we have to do with that? Check your unit circle and find the other angle. See if there is another angle. 49.4 degrees, that's right about here. Here's my reference angle, 49.4. What's my other angle going to be? Yes, it's going to be down here. So we're going to do 360 minus 49.4. Okay. It's 310.6. Okay. All right, that's for the first one. Now what? Got to do the next one. Oops. X is equal to the inverse cosine of negative 1 minus root 13 over 4. Okay. Go back to our calculator. And we're going to change this to minus root 13. And what happens? Any idea what the problem is here? It's a domain error. What's the problem? Let's figure out what negative 1 minus root 13 over 4 is. Negative 1.15. So what's the problem? Let's look at our unit circle. What's the highest x value we're going to have? What's the x value right here? 1. Okay, these x values, square root of 3 over 2, is that greater than or less than 1? Okay, square root of 2 over 2, is that greater than or less than? 1/2, 0, blah, blah, blah. How about over here? Negative 1. What's the largest x value we're going to get for cosine? 1. What's the smallest? Negative 1. Look at this. This is negative 1.15. It's not possible. You're not going to have the cosine of any angle equal something below -1. Cosine will always be between 1 and -1. So will sine. Sine will always be between 1 and -1. Okay? So this comes out to be below -1, which means it's not going to work. So this has no angles that work. When that happens, we get that domain error, okay, telling us there's an error in the domain, which means our x values aren't making sense to it. Okay, that's why we got that error there. You cannot do that. Okay. Think. Okay, I went over all of them. So let's see, did I give it homework? Yes, we did. Any questions on it, anybody? I know we did some brain hurting stuff here, right? Are you tired? I'm tired. A lot of thinking, okay? You have to be thinking about it all, okay? You have to think about it all. Okay, your homework is actually in Delta Math. Okay. Okay. Your homework is in Delta Math and it's called Solving Trig Equations. This will be graded for accuracy. Okay, so don't rush through it. And this will be due Friday morning at 8 a.m. Okay, so your homework is Delta Math. Okay, and we have some other types that we have to go over on Friday with the double angle formula. Yes. Yes. Oh wait, how many people will not be here Friday? Just the seniors, right? Okay. Yeah, there's a charger up here. Okay, other questions for me?